video, I want to show you how to solve a linear programming style question using Desmos. So here's our problem. You have 240 acres of land. You make $40 per acre for corn, which will be used as X. $30 per acre for oats, this will be Y. You have 320 hours available. Corn takes 2 hours of labor per acre, and oats takes 1 hour of labor per acre. So first, we're being asked to write an inequality for land. So since we're not specifying that you could be using twice as much corn or twice as much oats or 3 times as much, we're going to assume that there will be the same. So we'll say x plus y, and then we hit our little toolbar here and we find our less than or equal to, because we could use up to 240 acres of land, but we definitely have to use less than. We could use 240 exactly. So less than or equal to 240. Write the inequality for time. So we're using 2 hours per acre for corn, so 2x plus 1 hour for oats, so y. Grab that less than or equal to symbol again. And we're talking about 320 hours. And let's do it extra space. So we have some other inequalities that have already played in place then. So we're saying x is greater than or equal to 0 and y is greater than or equal to 0, because you can't have negative oats and you can't have negative corn. So the problem we have here is we can't see where the lines intersect. So what we're going to do to fix that, we're going to grab our wrench and we're going to first fix our axis. So using the x equation, we have x could be using the top equation here, x could be equal to 240, or using the bottom equation, x could be equal to 320 divided by 2 would be 160. So we're just going with the larger one. So we'll just say we'll go up to 250. Okay, now I'm starting to see some lines. Then we have y could be equal to 240 and y could be 320. So we're going to use y, we're going to make it up to 350. Now we can see what's going on here. I can see one line here, another line here, and the section underneath that's like this ugly, mucky color, that's the section we want to worry about. So our points of intersection. First, we're going to use this point here, which is going to be 0, 0. And we'll just label it. The next point will be this point right here. So that'll be 0 to 40. And we'll put a label on it so we don't forget what it is. The next point with this point at the bottom, 160, 0. And we'll put a label on it. And the last point is the point of intersection, which is 80, 160. And it's asked us if we want to label it, so we're going to label it. So there's our 4 critical points. Write the equation for the profits. So we're making $40 per acre of corn and $30 per acre of oats. So we'll say P equals 40x plus 30y. Oops, not P minus, P equals. Let's erase some of these lines out. Okay. Okay, use the critical points to see what the profit could be. So first we're going to just plug in 40 parentheses 0 plus 30 parentheses 0. So as expected, if we have 0 oats and 0 corn, we would have $0 profit. The next point we'll check is 0 to 40. So 40 parentheses 0 plus 30 parentheses to 40. So with 0 acres of corn and 240 acres of oats, we're expecting $7,200. Then we do 40 parentheses, we'll use this bottom point, 160, plus 30 parentheses 0. And we make with 160 acres of corn, 0 acres of oats, we're expecting $6,400. So we want to check one more point, the last one, 80, 160. So 40 parentheses 160 plus 30 parentheses, 40 parentheses 180, 40 parentheses 80, and then 30 parentheses 160. We're expecting $8,000. So what combination of corn and oats will maximize the space? Let's say we just say to maximize space, you should plant 80 acres of corn and 160 acres of oats, and we are done this problem using Desmos.